This video will be a quick rundown on simple interest and compound interest, how to use the formula, and with one example for each. If you need more details on simple interest and compound interest, there are more detailed videos on these, explaining how the formula works, precisely how you would use them, and so on. But in this video, I'm going to briefly go through these features. So a simple interest is when you have an interest applied to an amount, but that interest is calculated just from the beginning. It's calculated from the initial amount that you have. So I'm going to define some keywords. So I will represent interest. PV will represent the present value. So this is the initial value you start with. FV will be the future value. So that's how much you're going to earn in the end, or how much the value is going to be in the end. N will represent the total number of years, and R will represent the interest rate, and that will be in percentage. So let's say we're going to calculate the interest. So the way you calculate just the interest, so just to see how much you're going to add up on your amount. So if I'm investing $500 and I have a 5% interest, and I'm investing for 5 years, then that same interest will be added throughout the years. The interest is not going to change. So we're going to initially calculate it. We're going to take the present value, multiply it by the number of years, and then multiply it by the rate divided by 100, because we don't want to just take the rate as a percentage, so just 5%. No, we want to convert it to a decimal 5/100. So that will be our interest overall throughout the years. That's how much interest it's going to be. If you just want the interest added in 1 year, then you do the present value times the rate. But if you want the total interest throughout the year, so how much interest is going to pile up, then you'll have to do a times n as well. So in total, if I want the future value, so what I will have to do is take my present value and add it to my interest. So the interest is how much you're going to add up to your value after that many years. So this interest is on top of your present value. So altogether, it's going to be present value plus interest. And if I replace the interest with the formula that I have above, it's going to be the present value plus the present value times n times r/100, and then I can factor out the present value, so it's going to give me this. So this is the formula for the future value, and that's if I factor out the PV in the end. So if moving on to another type of interest, which is compound interest. So compound interest is when the interest changes after every year. So in 1 year, this is how much interest I'm calculating. And then in the next year, it's going to be different. It's going to depend on the new amount you're going to get and the new amount and so on. So again, these details are explained in other videos. But so this is the formula you're going to get. So I'm going to explain the different types, the different wording. So we already have the future value here. We have the present value. The R is the interest rate. Everything's the same. The N is the total years. Now what's different here is K. Now K tells you how many times within a year are you calculating this compound interest. So this is one thing that's different. You can see some similarities and some differences between this compound interest formula and the simple interest formula, especially that we're not multiplying by n inside the brackets anymore. But and we're not multiplying by a power, but something else is this compounded, so how often you compound your amount. So I've done a table to show the keywords. So sometimes if you're only taking the interest yearly, so your K is going to be equal to 1. It means you're not within a year. So if your compound interest is 5 years, so within the year, you're only taking this compound interest once. So your K is going to be equal to 1. If it's half yearly, then it means that in 1 year, you're taking this compound interest twice. So your K is going to be equal to 2. If it's quarterly, then you're taking it 4 times within 1 year. So your K is equal to 4. And if it's monthly, then you're taking this compound interest every single month. So it's going to be K equals to 12. So it's important to note this. You'll know what K you're going to have depending on the question. and it will be clear from the question. So make sure that you will divide by k inside that bracket, and you're gonna multiply k by n and raise that as a power right in the formula. So here are two examples. So I'm investing $1,000 into an account that pays 5% per annum. The first example is simple interest. The second example is compound interest. And for the first example, both of them are 4 years, but the difference is first that one is simple, one is compound. The second difference is for the compound interest, it's compounded monthly. So first, let's do the simple interest. So I'm going to lay out all my values. My present value is 1,000, my rate is 5%, and my years is 4. So I'm just going to take my formula and I'm going to substitute my values in there. 1,000, open bracket, 1 plus 4 times 5 divided by 100. So the divided by 100 is just to make sure that the rate converts to a decimal, so the 0.05. And that's going to give me 1,200. So after 4 years, my total amount is 1,000, and the interest I get will be added on there. If you want to find the interest, then you can just subtract the present value from the future value. So if I do 1,200 minus 1,000, that's going to give me 200. It means that was my interest. That's how much on top of my present value, that's how much I got on top of it. Now, let's see how different it is for compound interest. So we're investing the same amount, same percentage, same years, but we're compounding it monthly, and it's also a compound interest. So the k in this case is 12, because we're within 1 year, we're doing it 12 times. So if I use my formula, I'm going to substitute my values in there. Notice how I'm dividing by 12 inside that bracket, and notice how it's only 5 in the numerator in that fraction, and we're not multiplying by the years. But within that bracket, the bracket is being raised to the power of k times n, so that's 12 times 4. Plug that into the calculator, and you're going to get 1,220.90. That's rounded to decimal places for money purposes. So notice how they're roughly almost the same amount, but the compound interest is more, and that would have a bigger impact if it was more years, for example, or you're investing even a bigger present value, then you'd get even a bigger future value. And again, with this one, if you need to know what interest there was, so how much on top of that did you actually, how much the interest was on top of the initial value, then all you're going to have to do is take the future value, subtract the present value. And if I do that, I'm going to get 220, about 221, say, and it means that my interest on top of my initial value, so my interest overall within those 4 years was 220, which is obviously more than the simple interest. So I picked nice numbers just to see the difference, compare compare contrast between them, and otherwise it's just being comfortable with first laying out all the values that you have and making sure that you find the substitute correctly to find the final value. Again, if you need more details on each one, there are more videos about them explaining the difference and how the formulas work, and going through different examples of maybe finding the present value instead of the future value, and so on.